Hello folks, it's Monday, no on the air test since Saturday. Was it Friday was the last one. We haven't done the genuine Japanese Amstrad 901. Got a puncture on the car, and the problem is I've just taken the tyre in this morning and the wheels buckled, probably from that on the air test when Mr. Chippy hit that pothole at the top of the hill. So we could do without the expense. It was scheduled for a tyre this week. I'm not bothered about that, but I could do without damaged wheels. So that's in for repair. What we have, and I've shown you before in the EM27, I've shown you them several times, and they always howl, don't they? Whee! Well, this is one which has been, which is out of that batch I bought from Lancashire, with the intention of selling everything in there that's doable. I don't know if we'll get anywhere. I've got the customer's one here, which is immaculate, and if you remember, I've got to the conclusion that if we lifted the input pin to the audio IC, I could extract the audio and the radio work perfectly. I could also input an external signal into the audio IC and it worked perfectly. We put the two together and it howled. So we've seen all the online cures. Some of them are absolutely ridiculous, but obviously the capacitors are an issue. Obviously the battery leakage is very much an issue. It's interesting that these started doing this when they were 3 years old, and I think that battery leakage somehow, it's not just attacking the board, it's changing the reactance of the board, and I think that is causing a problem. I don't know. I really would like to know what the outcome is, but they're not that good sets anyway, as in reliability. They seem to work all right when they work. I mean, they were very much state of the art for 1919. So let's put this in here. I think that's the right date. So Maycom EM27. If I can get this working, I'll send this to our customer with the immaculate one as an interim measure. He's a disabled customer, and I don't like him to be without stuff. And we've been weeks because we've put a lot of quality time into it, but what can you do? There's a limit. Ex Lancashire. So I'm not going to open it up. We'll power it up, and I'll do it to 12 volts and not 13.8. So I've absolutely no idea. This may be the one and only worker there is. Now, when I did a demonstration video, I used the very, very latest final one, which didn't have the battery and had a memory capacitor instead. And of course, that was fine because it was a new set. So those very last ones with the green display, I think they're going to last all right. It's these amber display ones which will be becoming unusable after just 3 years. But that's how a lot of stuff's gone, isn't it? It's not like the 40-year life that we enjoyed with sets in the past. Right, power on. Well, you know what? Apart from a duff volume control, that's not doing the beepy beep. I'll just put picture in picture on. What I also didn't tell you, I don't think, is I've got exactly 10 minutes. And I've waffled for most of that. It's doing, have a look, just over, it's doing 3 watts spot on, and it's 601, and it's near enough on frequency. So that's all right. This is how you change band. No? Oh, it's second function, is it? And of course, when we've said 3 watts, it's on 12.8 volts. So let's put it on 13.8 volts. It'll take the power off doing this. So then we'll have to power it back up again. And we'll go to channel 20. Still 3 watts, so that doesn't make any difference. So I'm going to dial that into the signal generator. $27.79. I'll put it exactly on frequency because we're not doing a performance test at this moment. And you can see the signals coming in. I think we've just got a dirty volume control, to be honest. That's 1 microvolt. So these, yeah, that's working fine. Now I'll just take the lids off because I'm fascinated. I don't think there's any backlight working on this. I hate these long-term jobs where, you know, the customer knows that they're swines. It's like the CB1100 we've got in, and you've got to draw a line at some point. But this gentleman has been very kind in the stuff he's sent in the past, and I do try my best to look after him. He's an A licensed radiometer. Of course, this could be the later version with the green display. That's not a... Is that a battery? Let's unsolder this. Let's not unsolder the speaker because the soldering iron's not on. So what version's this? Yeah, this looks so much spot on. Surely that's the capacitor and not the battery. C052, but that doesn't mean anything, does it? Yeah, it's a memory capacitor. It's 20.22 farads. Well, that's why this works. Well, we'll get this sorted out and we'll send it this gentleman. And at least he's got a nice working set. Good. Well, at least I've found one. Right, I'll come back later and we'll make a start on it. Right, so back onto this. I think we'll start by doing the tune-up. None of the lights work on it, or every single bulb seems to have failed. I've checked the voltage on the back of the bulbs, and the voltage is there. So it must have been on for a lot of hours, because it's going to be, those lamps are going to be probably 1,000-hour life. So we'll have to probably get some ordered, because I don't want to have it looking bulbless. So we'll probably do this in several parts and see if we can get the set working. VR1 is power. I've been looking at the circuit diagram, I've been looking where the battery is, and on this circuit diagram it is the capacitor, wherever that is there. And it says C317 instead of BAT317 on my layout. So that's good news. Only that one which I bought brand new from the wholesaler in the very, very final days of these being available is the only one I've ever seen of these that work. We have had a customer repair and I was able to successfully make it work without the memory backup capacitor. But that's it. So I had actually put the other camera on the inset picture. So let's see, this preset is not labelled and I'm looking for VR1, so it's not where I'd expect it to be for power, but if it's not labelled then that's what we're going to go for. So we're at 13.8 volts. I'll tell you what, we'll just make some notes. I'm going to tune this up on UK. Don't think anybody uses CPT. Well, they don't round here anyway. It won't not work on CP2, but we'll optimise it on UK. So it's 3.1 watts. And let's have a look at that. It is 3 watts. And on channel 1, it's 3.1 watts. Doesn't have low power, it's not that kind of set. And if we go back to, there's different approval, it's PR2794, so it's 80 channel, FM only, 943 milliamps. We won't be doing anything like adventurous. And just have a look where the frequency is now. We've had the test gear on for an hour. 27,79111. So you know it's not really out at all. Now which one's the reference? Ha 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 ha. I've got 2 crystals there. I'd hate to upset anything. So crystal 901 is the reference crystal. On this layout, it's shadowed. So this is going to set whatever that crystal is, 201. Yes, that is 10.24. So that has to be set up by monitoring pin 1 of the Tango IF subsystem. Otherwise, the receive IF can be out. So if that gets fiddled with, the IF suffers. So goodness knows what the third crystal is. The third, that's your reference oscillator. So is that what we're looking for? So the reference oscillator is pin 1 of the round the corner chip on the other side. Oh, it's on the front panel, isn't it, on these? I'm going to leave that for now. There's a lot. I'm going to have to get a lot more gear out to do this, to get it spot on. It's probably not being played with, but let's go back to the main meter and see if this is power, which I can't imagine it being. It doesn't do anything. That shouldn't be power, but it is. So at the moment, full pelt on that is 3.4 watts. So we'll go up the transmitter, and it's going to be, it's quite clear what it is. It's going to be that row there. Ends in T. It ends. 602, 603. Going to be those three. When these first came out, I thought they were going to be absolutely fantastic, and I was disappointed. See if these are placed properly. Right, well, we can say it's 3.5. I'll just make sure this isn't at full whack. I've discussed this many times before. There's a point at which it makes no difference. You don't want to exceed that point, otherwise you're thrashing it. It's going to apply more voltage but do nothing. It's like driving up the hill in the wrong gear. Instead of changing gear, this is no good talking to Americans like this because they have automatic cars. But where we have to prove with manual cars that we have a full driving license, and we're frightfully proud that we can drive manual cars, my analogy here is that you're driving in the wrong gear, and instead of changing gear you just put the pedal down even further, and it doesn't go any faster, but you're still using more fuel. Right, so let's make a note. I should have made notes on the, I never thought we'd see another one. These are one of those sets I refuse to take in because I know what the outcome is. So TX power, TX, TX, TX. This will be the coil done with a spectrum analyzer. Just checking that there's no nastiness here. That's fine. So let's have a look at the other channels. Channel 40, 3.4 watts. Channel 1, 3.6 watts. That's about, to be honest, that sounds good. So it's going to be alright on CPT. Alright, just to prove it, let's go into CPT. We've got to press the right buttons. Function, UK, EU. So on channel 1 CPT, it's doing 3.6 watts. would have been 3.6. And the power consumption, let's go back to proper set of channels. And now we've got to dial in channel 20, just like that, and we'll see what the current consumption is now. It's 1.036. Deviation, wow, it says it's 2, that's probably about right, but we'll check it on the test set behind me in a bit. There's no adjustment for the power meter. I don't even think it's real on this. So I'll put FSD. Let's have a look at the circuit and just see if I can actually see a power meter on it, or whether it's just programmed like modern sets are. This might have been the first of the fake power meters. I've even taken output transistors out of modern radios just to see what the result is, and it still gives you a full meter of power because the CPU is just programmed to read that. Right, meter. Well, here we are looking at the meter here. We've got regulated B+, we've got main regulated power. Actually, it doesn't go to the transmitter, so that's a red herring. That comes from the band switch. And receive antenna out. So there is, in that is the transmitter, there is no power reading circuit in the transmitter. So the fact it comes up with a full set of bars is because it's either done at an early stage or it's straight from the CPU and it's BS. So on the receive side, we can follow this back because we've got a jack for the S meter. S meter in. So up here we'll have S meter out. Squelch out. It's there, 301, S meter out. 301. So that looks adjustable. And 301 is which? It's not going to be... Is it that one? It could be the one I fiddled with. We've got 501. 301. So that's going to be the S meter. Right, so let's see where we are. I want RF gain to full. I better plug an extension speaker in through the test equipment socket, through the test equipment through the extension speaker socket. Now, one of the problems I've got with this, of course, is the volume control, and I'm going to take the front off to look into what's happening there. So I'm going to have to try and find a sweet spot where it actually works. I might have enough volume. I don't know whether it's very dirty or whether it's broken. If I kind of breathe on it, it might just work. No, I can't turn it down. So let's get a reading before it packs up. For 12 dB it's 0.5. For 10 dB 0.43 and 1 microvolt. I don't touch the squelch. So I'm going to have to try and tune it without blinking. I didn't show you that on the meter. See if we can do the detector first. Put an S9 equivalent signal on. Now the detector is going to be this coil, which is, it looks like 501. It's probably the one that stands out on its own. It's probably going to be that one. So is that 501 or 001? It could even be. Just turn the oscilloscope down because I'd normally turn the volume down, but I daren't. That was a bit out, wasn't it? Yes, Mr. Tango. So we'll turn that down to about 4 dB on the synod meter. We'll go through this. I'm assuming we're starting here. I can't see any change there, but it will be less garbled now we've done the detector. Let's get a new figure. Could be better, it could be worse, but at least it won't be garbled. So for 12 dB it's 0.41. I'm not going to be that generous, I'll say 0.4. It's 0.415, so we'll call it 0.42. So it has improved. For 10 dB, 0.35, and for 20 dB it's still 1. Now I may be able to, if I touch the squelch it's probably going to disappear. No, I can't do the squelch. So at the moment, let's look what the S meter says. We've got a full set of bars, whatever that means. And this preset should be the S meter. And it is. But what? Where's the S9? Oh, it is next to, it is labelled. It's 1 down. There it is. It's 1 down. There's full. That's plus 30. So on the signal generator, we can go down. There we are. We've calibrated it. Way. Something else we can tick off. I couldn't get it before, so we'll do this S9 now. Meter lamp, no. Switches, yeah, well, we'll come back to that. It doesn't have that. Good. Well, I'm going to have to strip this down. This may be where the video ends. This might be the part 1, but at least we're getting somewhere. At least mate is going to get a set newer than what he sent in. I think he sent in a Radio Shack one, the TRC 2015, which are all the early production. And so I want to look at some of these exact frequencies of these reference crystals. That's microphonic, isn't it? Hello, anybody in there? That's awful. Wouldn't like to drive this in a car. Let's hope that some of the screws are loose. So we put down their S meter. So So we've done transmit power, we've done S meter. So one's going to be squelch and one's going to be deviation. So I'll just see if we can help with the microphone. It's usually loose fixing screws. Can't tell anything though with this volume control. Well, it's not rattling now, so there you are. All the thing fixed. Screws missing after the mic plug. So to get into this, and we'll just turn it off. To get into this, we've got to take out all these fixing things from the volume control and so on, and the mic one. So there's a lot of faffing, a lot of work, a lot of hoping you don't break anything. So I'm not going to necessarily do this on video. The last thing you want to do is watch me taking screws out and things. And I've got to be so careful not to break this front panel board, which is mounted there with the connections there. So we don't want any pressure whatsoever on that. But for me to get to these lamps properly and measure them, we've also got to take out some screws. If I wasn't a church organ builder, I probably couldn't get that screw out. That might be enough. So our next thing is to get all these out. So I'll stop the video, and if there is no more, I'll come back on and say goodbye to you all. This may be where part 1 ends. Right, so we will bring this to a close as part 1. So I've taken a lot, I think it took about 90 minutes to get the front off this. It's got those horrible little, I don't even know what you call them, but the nuts that go around the controls, which you need a pin driver for. I once ordered a pin driver from the United States, paid about 30 quid for it, and it never arrived, so we still don't have a pin driver, and it's such a faff. But one of these was particularly difficult. Anyway, it's come off. So we're going to power it up, and I've gone through it for dry joints, and it's the squelch which is playing up now. So if you look, it's volume's fine. So, it's coming in and out with the busy symbol. Let's put a signal on it. Mind you, signal generator's probably off frequency now. No, it isn't. But we haven't got an aerial on it. Let's put it on full whack. And put it on channel 20. So I think what we're going to have to do, you've got a plastic bezel here which helps with the illumination. And by the way, every one of these light bulbs has failed. 1, 2, 3, I've taken one out so I could measure it, They're ordinary incandescent bulbs, 3mm diameter, and there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So I've ordered those from RS. No, I'm not going to put LEDs in. This must have been on day and night for 10 years for those to fail. So what I'm going to have to try and do is to drill through where the accessy bit is, so we can get some cleanser in there. And if that fails to do anything, we've got plenty of these set scrap, haven't we? But to take this off, you'd have to take the display to one side, and I think there'd be a danger of breaking the display. So I want to try and avoid doing that. But the set's working fine. It's just this cosmetic stuff and the controls. So this is going to end part 1. You've seen me tune the setup. Actually doing 3.6 watts. It's working well on receive. So it's just this. But I've ordered from RS. Will probably be a couple of days. But I was so pleased to discover that this is the one with the battery in it. And it's actually going to be repairable, hopefully. So we'll go into the details of setting the frequency of this crystal, and then I presume that trimmer does the actual transmit frequency. We'll see. So thanks for watching part 1 of the EM27.